Okay, again, class, good afternoon. I have some reminders on the board. The meet and greet discussion and the orientation quiz are both due on Sunday, August 31st. And I'll show you later where to go to do those. And then we don't have class on Monday, which is a Labor Day. And then module one group assignment will be due on September 8th, Monday. I haven't sent an email about this yet. So expect an email by tomorrow. So if by tomorrow evening you don't get an email from me regarding the group and the questions, you can email me back. Okay, but expect it by tomorrow. Okay. Now let me share to you. Hold on. My screen. Hold on. Okay, this is your Canvas page. If you want to do the meet and greet discussion, you go to your modules and then go to the introductory module and then orientation quiz. Okay, just click this one and you should be able to do it. And also the meet and greet discussion, if you click that one, it will take you to the meet and greet discussions. Okay, and you're supposed to answer these two questions and reply to at least two of your classmates. This is not graded. However, it would be best if you answer them because your classmates and me would actually read it and learn from it. But the orientation quiz is um, graded, which would be 10 points of your grade. Okay. So, yep. And also, I just need to remind you that for every module, there's a module handout, which you could click this one and you can download the module handout. And what's the module handout? It's actually the one we are actually using every day. Okay. So today we'll do page 6 of the handout. So that's where you would go to get a copy of your handout. And also, let's go back to the module. And a great resource would be the lecture notes by Nada. If you click this one, because every day she takes notes and we upload it here, okay? So last Monday, we uploaded the notes. And also this one, I just uploaded it a few minutes ago. You may want to open it or download it later on when we use it. It's actually this one. I'll show it to you. This one, because we'll be using this. So it's like a cheat sheet, surely. So you won't have a hard time getting the trig values because you'll be reviewing trigonometry in a while. Okay. And also a great resource would be if you go to the module, the Zoom lecture recording. So if you miss some recordings or lectures, just go here and you should be able to access the recordings. And what else is important? And again, the group assignments, I will email you on the groupings and the questions. And for each module, you may want to just click this one. Okay. And this would remind us what we're supposed to finish on that module. Now for the daily mini quizzes, we don't have yet, but we have one on next week, September 4. So after we finish 2.1, section 2.1, we will be doing the daily quiz for section 2.1. But for now, we don't have anything yet, okay? I'm not giving any daily quizzes for the review of pre-calculus. Any questions before we continue? Again, for extra credits, if you recite, if you participate in class, then that's when you would get bonus points or extra credits, and I would add it to your module exam. Okay?
I have a question.
Yes, Leonardo.
Are we doing the groups for the assignments today?
No. Okay, so again, it's like this. The group assignment You will be grouped into 4 or 5 per group. Okay. I will tell
Okay.
you your group mates, and again, I will email you tomorrow about it. And the email will include the instructions on that. Usually, you talk about it, and you have a week to do it. This is due Thursday next week, I think. So you have enough time. Thursday or hold on. When is that due? That's due September 8th. Okay. So yeah, more than a week actually. So you have
All
enough
right.
time to discuss it and then send me your final answers by on or before September 8th. Okay?
Okay.
Does that make
Perfect.
sense? Okay. Again, I haven't sent you anything yet, except expect the email by tomorrow evening.
All right.
And this
Thank
will
you.
again be due on September 8th. You have more than enough time to finish it. Are we good? Does that make sense?
Yes. Yes. It does.
Okay, dokie. Any questions before we continue with the actual lecture?
Wait, will there be like office hours after today or?
Well, if you okay, so like for the office hours, you could email me in advance, like a day before. So I would set up an appointment with you regarding the consultation. Who was asking that? Jawan, was that you?
Yeah.
Yeah. Does that make sense? Yeah. Tell me in advance if you want to see me or Nada, but she has office hours as well. Nada, can you talk about your office hours, please, so they will be aware of how this works for you?
Yes, I just submitted the proposal to Joe, and he is supposed to approve my hours. So I don't know yet if he will approve of it. But if you have any question, please email me. There is email in syllabus, and also I posted a announcement. So look for it.
Okay. Yeah. Does that answer your
Anyway, the
question?
first week they don't usually do helps, so you just have to bear. Sorry, help is not available the first week of school.
Help. What do you mean by that, Nada? For the
The learning center is not.
another learning center. Okay. Yeah, but they can always email you or me.
Yes,
If
they
any
can always
questions,
email
they
me.
might get confused on that statement, Nada. Yeah, because it's like this. There's a learning resource center at the library. Okay. You
Yeah.
go there, you go turn to the right, and there's people there to help you if you have any problems or any questions in math. But I think that will
Yeah, but
be
starting
available by next week, right? Does that answer your question, Joanne?
Yes. Thank
Okie
you.
dokie. Thank you. So, yep, let's, if you don't have questions, let's start. So you may want to open your handouts and we'll be starting with page 6, the definition of composition function. Anyone who wants to help me read the definition of composition function? Anyone?
I will.
Okay, Leonardo. Okay, hold on, Leonardo. I'll just make sure I write your name so I could give you your bonus point. Okay, Leonardo, can you read
Yeah.
composition of functions?
Yeah. Given two functions f and g, the composite function f o g
Let's
is
just
that?
read it at circle. It's easier. F
Oh yeah, f
circle
circle g, also
Mhm.
called the composition of f and g, is defined by f circle g and
Of
x
X mhm,
equals to f
of G of X.
yeah, that, yeah, f g of x. Yeah. That.
Okay, it's like this, class. You have two functions, F and G, which are both functions of X. Now, we define F circle G of that variable X to be equal to F at G of X, meaning all the X's in F will be replaced by G of X, okay? So let's do letter A, and let's do F circle G and G circle F. Can you read letter A, Leonardo, please?
Yeah. Sorry, letter
Yeah,
A,
letter
right?
A, please. F of X
Yeah.
equals.
Yeah, f of x equals 3x plus 4. G of
Mhm.
x equals 2x minus 1.
Okie dokie. So F of X is 3x 4, and G of X is 2x minus 1. Okay? Now we would want to do F circle G of X first, okay? And later on, we'll do G circle F of X. And let's see what happens here.
G is 2x minus 1.
2x minus 1? Okay. Sorry. Typo. So 2x minus 1. Thanks, Nada. Okay. By definition, F circle G of X is F, which is that first function there, at G of X. Meaning all the x's in F will be replaced by G of X, by that whole thing. Meaning that's 3. This x there will be replaced by that. So 2x minus 1 plus 4. Okay, you may want to think of this as one big X. Okay, X, and that is called X. Okay, and 3x plus 4. 3x plus 4. And I'll just clean up. So this is equal to 6x minus 3 plus 4, or 6x plus 1. So that's your final answer. Now let's get G circle F of X. This means that you would have, by definition, it's G of F of X. Meaning all the x's in G will be replaced by F. That means, because G is 2x minus 1, so 2x, which is your x will be replaced by that whole thing. Okay, minus 1, 2x minus 1, 2x minus 1. Again, you may want to think of this as one big x. 2x minus 1, 2x minus 1. So this equals 6x plus 8 minus 1, which is 6x plus 7. Any questions, class, before I proceed? Okay, now, Leonardo, I have a question for you. Is F circle G equal to G circle F? Leonardo, are you
Sorry,
still?
what do you mean?
Is F circle G equal to G circle F?
Oh,
Yes or no?
no.
No, right? Because this is 6x plus 1 and this is 6x plus 7.
Yeah.
Meaning that means that the circle, the composition function, or the composition operation is not commutative. It's not equal to G circle. Let me write it here. We remove this. Okay. That means that F circle G of X is not commutative. Okay. Meaning if you have a function F and G and different from each other, then F circle G is not equal to G circle, as what you saw here. Any questions, class? We're good? Okie dokie. Now, can you try letter C, class, please? F of x equals x squared, and G of x is x plus 2. Can you try it? I'll give you a minute or two to figure this out. And Leonardo, I'll get back to you, okay?
Perfect.
Yeah, try G circle, F circle G and G circle F. Let's see what happens. And tell me when you're ready, Leonardo, okay?
I'm sorry. So which one? I'm sorry.
Okay, we're doing
Is it on the
letter
stream on
letter
my?
C. Yeah, I think we're doing letter C.
Oh, okay.
Mhm. This one, f at x equals x squared, and g of x is x plus 2. And we're doing both f circle g and g circle f. Did you get anything, Leonardo?
Yes.
Okay, okay. So,
Yeah.
What did you get for f circle g? Just
I'm not sure if it's correct. I got x plus 2 in a parenthesis, and then the 2.
right. Very good. Because by definition, this is f of g of x.
Yeah. One question: how do you call the square, but like not square, but like the position it is in? I'm sorry, my English is not good.
So your question is, how do you spell this out? Is that what?
No, the position where the square is, like the exponent, or I don't know how
Oh, yeah, the exponent. Yeah.
Okay. Yeah.
That 2 is the exponent here. Very good, Leonardo. Okay, f of g of x, meaning all the x's in f will be replaced by that whole thing. So x will be that whole thing, x plus 2, and exponent is 2x plus 2 squared. And do you remember how to spell this out, Leonardo, using special products? This is equal to
Spell the answer out?
yeah, just spell it. I just want it spelled out at this point, just for practice. But you really don't have to. You're correct.
Yeah. X
This is
squared
a correct answer already, class.
Yeah,
Okay,
x
but
squared
I want it spelled out.
X squared plus 4.
Very good. Plus 4x plus 4. Okay, don't forget that because it's like this, class. This is if you do long multiplication. This is x plus 2 times x plus 2. Okay. Now, what's x times x, Leonardo?
X squared.
Very good. What's x times 2?
2x.
Very good. And you have another one here, right? What's 2 times x?
X squared.
Hmm.
Oh, sorry, 2x.
It's okay. What's 2 times 2?
4.
Very good. And then you add, right? This is x squared plus 4x plus 4. Okay? Remember that. Okay? If, for example, you don't know how to spell this out using special products, which we learned from algebra, you can just do long multiplication and it should be okay. Okay? Are we good? Now, what is g circle f of x? By definition, that is g of f of x. So what do you have here, Leonardo?
Yeah, I got x squared plus 2.
Very good. Because all the x's here at g will be replaced by this whole thing. X, which is x squared plus 2. Good job, Leonardo. Oh, whoa. Okay, good job.
Thank you.
Any questions, class, on letter C? That's all you do. Okay, do not overthink on this one. So let's have another one. Let's see. Let's have letter F, class. I don't know. That's x squared. Or again. Okay, I want letter D. So we have a different exponent. So letter D, f of x is the cube root of x, and g of x is x cubed plus 1. I'll give you a minute to try this, class. And Leonardo, I'll call you again, okay? You have anything, Leonardo, for F circle G?
Oh, I'm sorry, I couldn't do it. My roommate turned on the fire alarm, so I had to leave.
It's okay. Now let's do this together right now, okay?
Okay.
So F circle G will be all the x's in F will be replaced by the whole thing. Meaning this is the cube root of x. So this is the cube root of x. So but x will be replaced by G, right? So this will be x cubed plus 1. That is your final answer. Okay? Now, what's G of f of x? Meaning all the x's in G will be replaced by this whole thing there. But what is G? That's x cubed, right? So x cubed, but x is this whole thing. So cube root of x cubed plus 1. But Leonardo, what's the cube root of x cubed?
To be honest, I have no idea.
Okay, let's recall this. Okay, now, very simple. Square root of x, Leonardo. If you square it, what happens?
Yeah, that's the thing I don't know.
Okay, it's like this. If you would remember from algebra, x square root of x will just be x to the 1/2, right? Did you recall that class? And then you square it,
All right.
basically, right?
So it'll
And
be
then-
x and 1/4.
No, okay, because this is 1/2 times 2, right? What's 1/2 times 2, Leonardo?
Oh, I thought it was 1/2 times 1/2.
No, this is not 1/2. This is a 1/2, Leonardo. That's my basic question. Is that it's not a 1/2?
I'm sorry, I can't. I don't know what I'm looking at.
This one. What do you mean you don't know what you're looking at?
Is it? I have something blocking that part of the screen. Sorry.
Okay, let's do that
How-
again, okay? Let me
Okay.
write it down.
Um.
This is 1/2 times 2, right? Correct?
Yeah.
So what's 1/2 times 2?
1.
Very good, because this cancels out and you're left with 1, right? So this is nothing but what? X, right?
Yeah.
Do you agree? Or
Yeah.
x to the 1 or just x, right? Now, let's do it here as well. So let me rewrite it. Cube root of x, then cube it. Okay? Now, this thing inside is x to the 1/3, right? Correct? Leonardo?
Yes.
This one, that
Yes,
whole thing
yes,
only.
yes.
That thing only, okay? And then I cube it. What's left?
X.
Very good.
The thing is, I thought when you squared something, you were multiplying it by the number.
Yeah, exactly. Yeah, exactly. This is multiplying. This one is you're multiplying square root of x by itself. Meaning, if you would look at this, okay, this is the same as square root of x times square root of x. Do you agree? If you want to look at it in a different way,
Yes, I agree.
right?
And what
And-
about the parentheses in the bottom, with the 1/2? Why
Yeah,
does it multiply?
You just transform this thing to x to the 1/2. Because remember from algebra, x, the nth root of x is x to the 1/n. Do you recall this from algebra?
Yeah.
Okay, that's what we did here.
Yeah. No. Yeah. I remembered. I just got.
Okay, because this one is a 2 there, right? Square root would have a 2 there.
Yes.
It's
Thank
on coming back now, Leonardo.
Yes.
Okay,
Yeah.
okay. And if you looked at it this way, class, okay, recall this is x to the 1/2, right? Do you agree? This part here, and this is also x to the 1/2, correct?
Yes, that was my mistake. I was multiplying it by x And
No.
by the 1/2.
Very good. I know what you mean because that was my mistake when I was your age before, okay? This is different. This is equal because they have the same base x. You just add the exponents, right? So this basically is x to the 1/2 plus x to the 1/2. What was 1/2 plus 1/2, Leonardo?
1.
Exactly. So this is just x to the 1 or x. So you can look at it this way or look at it this way. It's all coming back now, right, Leonardo?
Yeah.
Okie dokie. Now, what is cube root of x? Cubed. Leonardo? What is this now?
That's x. No, that's x. Yeah.
Very good. X. And you have a 1 here, right? X plus 1.
Yes.
And they're not the same.
Professor, I had a question.
Yes, Hassan.
Can't we simplify the first one to be x plus 1 as well?
Sorry, I did not hear you. What was that?
Can't we simplify the first problem to be x plus 1 as well? If no, I mean f of g of x. Yes.
This
if you
one.
try-
Ah,
yeah.
no. Because it's like this now. What he's saying is, can we simplify it? This is the cube root of the whole thing of x cubed plus 1. I know what you're thinking. Can I remove this? I know what you're thinking. You're thinking of this. Maybe this is equal to the cube root of x cubed plus the cube root of 1, right? Am I correct?
Yes.
No, it's wrong because this is x cubed plus 1. And this is addition, not a multiplication. So you cannot distribute that cube root. Okay,
Yeah,
this
thank
is
you.
not equal to that.
Yeah, thank you. I just realized it was multiplying.
I know. You know what? I also had that same confusion when I was your age. So I understand. That's why I know that this is what you're thinking. Because what is this? This is x, right? And what's the cube root of 1? We also know that it's 1, right?
Yeah.
But again, it doesn't work that way. Okay? Make sense?
Yes.
Okay.
Yes.
Okay. So let's just leave it at that. Any question?
Professor, I had a question.
Yes, Karan.
I don't mean to jump ahead, but I was just wondering on the example, it shows f of f and g of
Okay,
g.
let's do that then. Okay, let's do that. Jaskaran, okay, let's hold on. Are we good now? Before I answer Jaskaran's question, we're good. Okie dokie. Now, Jaskaran was saying, I see that it's asking for f circle f as well. Let's see what happens there. F circle f, right? Jaskaran. Okie dokie. By definition, what is this? By definition, this is f evaluated at f as well, right? Now, what is this? What's f, Jaskaran?
F is cube root of x.
Very good. So cube root of x, meaning you have to replace the x with the whole thing, right? Does that make sense? So this is the cube root of the cube root of x. And let's simplify that. Let's clean it up further. What is cube root of x? X to the 1/3, right? Correct, Jaskaran? But you are also raising it to another 1/3. Correct?
Yes.
Okie dokie. Now, do you remember from algebra? What is x raised to a and x raised to b? What is this equal to?
Would you multiply the two of them?
Very good. So this is x raised to
1/6.
1/9, right?
Yeah, 1/9.
Correct? Because this is a times b, right? So this is equal to x to the 1/3 times 1/3 or x to the 1 over 9 or the 9th root of x.
Okay, that makes sense. I wasn't sure if you just
Yeah,
plug it
that's,
back into itself or how that would
yes,
work.
exactly. That's all. Meaning, in this example, this doesn't matter, right? Because you're
Right.
using f anyway. The same with g. Okay?
Mhm.
Any questions, class? We're good? Okay, let's have one last for this. Can you try letter G, please? F of x is the absolute value of x, and g of x is 3x plus 1. Jaskaran, I'll expect you to answer this, okay? Is it okay?
Okay.
Let's
Yeah.
do f of g and g of f. I'll give you your bonus point as well. Hold on. Let me just make sure I'm doing that. Okay, okay.
Just to make sure on this one, you want to do f of
F
g and
circle
f.
G. Yeah, F
Okay.
circle G and G circle F.
Okay, sounds good.
Okay. Oh, sorry. Are you ready, Jaskaran?
Yeah, I got my answers.
Okie dokie. So what's f of g of x?
So that would just be the absolute value of 3x plus 1.
Very good. Because here f is this whole thing, and you replace x with that whole thing there. Put it inside. What's g of f of x then?
Will that be 3 times the absolute value of x plus 1?
Good job. Okay. 3 because you just replace that x with that whole thing there. It's like a cookie cutter, right? Yeah. Any questions? Hassan, you were the one who was asking a while ago, right? Hassan, you asked a question a while ago.
Yes, Professor.
Okay, I'll give you a bonus point, but I want you to read. Hold on, I cannot find your name. Okay, Hassan. But any questions, class, before Hassan helps us with the next exercise? We're good? Okie dokie. So don't overthink on this, okay? Now, Hassan, can you read 1.13, please?
Okay. Determine whether the equation defines y as a function of x.
Okie dokie. Y as a function of x. Do you remember the definition of a function, Hassan?
I don't remember it.
Okie dokie. Let's recall, okay? Let's
Yeah.
recall the definition of a function. Remember, for a function, before we could define a function, we're supposed to have two sets, right? Sets A and set B, right? And then there's a mapping or a matching of elements of A to B, right? And we said
Yes.
that it's a function if you have this, okay? For any function element of A, there exists a unique element of B. Unique element of B. So this is okay because unique, 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 and unique, right? So this is a function. Now, it's not a function if, for example, you have this one mapped to that, and then this one is again mapped to another one. This happens. You don't want that, meaning if that happens, you don't have a function. Okay, so we do not want that. We just want unique, 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 unique. Does that make sense, class? We're just recalling. Okay, so now let's go back to the question. This is saying that determine whether the equation defines y as a function of x. Meaning what happens here basically is you want to express the equation as y equals f at x equals something. Okay, let's do letter A first. Can you read letter A, Hassan?
Yes, I can. Are you gonna write this?
Yeah, just read letter A.
Okay. 2x minus 7y equal to 4.
Equals 4. Okay. Let's look at that. Okay. Now, what you will do here is to isolate y, and let's see what happens, okay? So y would be, well, I could do this, 7y, put it there, equals 2x minus 4. Do you agree with me, Hassan, that you could write this as this one? Right?
Yes, we could.
Because we could, transpose it and that one. And then y equals 2x minus 4 equals 7. Do you agree?
Yes.
Okie dokie. Now this is f. Just think of it as f of x. As y is a function of x, right? It's a function of x. Now,
Yes.
if I throw in a value for x, would there be only one value for y? Yes or no? What do you think? If x is 0, what's y? Hassan, are you there?
Yeah, it would be minus 4/7.
Very good. Only one, what, right? Only one value of y would exist.
Yes.
If
Yes.
x is, say, 1, for example, what's y?
There would still be one value.
One value, right? Which is -3/7, I think. Now -2/7, right?
Yes,
So is this a function or not?
it is.
It is a function. Because for every value of x, there's only one y. There's only one y. Make sense, class?
Could you give us an example for something that wouldn't work?
Okay,
So
okay,
we-
of course. Yeah, we'll get there. Okay, let's just do this one by
Okay.
one. Okay, so let's do, say, letter C, Hassan. I'm not sure if this is a function or not, but we will analyze. Okay.
You said for every
Okay.
value of x, there's one y, right?
Yes, that is exactly, yeah, that's what you want for it to be a function. Now, let's just do this one and let's see the behaviors, okay? So this is really clear later on. Let's just do the letter C. Okay, so
x, yes.
can you read letter C, please, Hassan?
X squared minus y is equal to 9.
Okie dokie. Now, let's isolate y again, okay? So do you agree with me that y equals x squared minus 9?
Yes.
Okie dokie. So this is f of x. You don't have to do this, but because y is a function of x. Now,
Okay.
if I throw a value for y, would there be only one y? X, would there be only one y?
Yes.
Right? For example, if x is 0, what's y?
If x is 0, then y is minus 9.
Very good. If x is 1, what is y?
Minus 8.
Minus 8, right? If y is minus 1, what's y?
Then it is still minus 8.
Still minus 8, but there's just one value, right?
Yes.
Correct? Meaning, if you look at it this way, if this is -1 and 1, it is mapped to both -8, right?
Correct.
Okay, dokie. So this is a function, right? You agree?
Yes.
Okay, dokie. Now let's have another one. Hassan. Let's
Yes.
read letter D, please.
X is equal to y squared.
X equals y squared. That means, let me write it here, okay? So you would see it better. This is my cut somewhere. So X is y squared.
Yes.
Now, Hassan, do you agree with me that y equals the positive negative square root of x?
Yes.
Because remember from algebra, if you want to isolate y, extract the square root, and it should always contain two parts, positive and negative, correct?
Correct.
Because, for example, x is -1 squared, x is 1 squared. Both are 1, right?
Yes.
That's why you have to take the negative and the positive part. Negative and the positive part. Now, if I throw in a value for x, Hassan, for example, 0, what's y?
And y is 0.
Exactly, just 1, right? However, if I throw in a value for x, a non-negative value, say 1, for example, or just say 4. If x is 4, what's the square root of 4?
2.
So the y would have how many values? Positive 2
Uh,
and negative 2, right?
yes.
Correct? So meaning, if you look at this, if you look at that case, okay, if x is 4, it's mapped to how many? -2 and 2, 2 values, right?
Yes.
And it went like this. Therefore, it is not a function then. Not a function. Does that make sense, class?
Yes, Professor.
Okay, let's have some more. Let's practice, Hassan, okay? And
Okay.
letter F, Hassan. Can you read letter
X cube minus y is equal to 0.
Okay. X cubed minus y equals 0. That's letter F. Is this a function? Hassan, are you still there?
Yes.
You
I'm still here.
agree that y equals x cubed, right?
Yes.
Is this a function or not?
It is
Very good. Why?
because x cube produces only one value.
Exactly. Like if x is 0, you have y is 0. If x is 1, y is what? 1, right? If x is -1, y is -1, so on and so
Yes.
for any real number. So this is actually a function. Are you getting the pattern, Hassan?
Yes.
So
am.
let's do this really fast, okay? I want you to answer from A going down to Q, okay? So the first one,
Okay.
function or not?
It's a function.
It's a function, right? Because
Yes.
if you isolate, this is actually a line. So a line is a linear function. You learned from pre-calc that it's a function, right? So letter
Yes.
C,
It is a function.
it is also a function. Letter E,
It is a function.
it is a function. Okay, for those of you who may be confused, let's analyze letter E, okay? X equals y cubed. X, letter E, x equals y cubed. If you isolate y, this is just the cube root of x, right? Class, Hassan, do you agree? You don't
Yes.
get the positive negative part because the exponent is odd,
Cube.
right? Cube or anything that's odd, you'll just get one part, this one, the cube root of x, okay? And
Right.
for any value that you to throw to x, you will only have one value for y, right?
Yes.
Okie dokie, that's why you are right. This is actually a function. Letter G.
3. Oh,
Function.
wait, can I could I like simplify it?
Of course.
Okay.
Now simplify it on your own right now. Now tell me, is it a function? And then we'll discuss it. Yes or no?
Okay.
We're doing G, right? Am I correct?
Yes. Yes.
I forgot what we were talking of. 3x minus 5y squared equals 9. Have you decided?
Yes, it is a function.
Let's analyze this, Hassan. Again, you isolate y, right?
Yes.
So do you agree with me that this is 5y squared? I'll just do it slowly, okay? 3x
Okay.
minus 9. Do you agree?
Yes.
Or y squared equals 3x minus 9 over 5. Do you agree?
Yes, I agree.
Now, y now is the positive negative square root of 3x minus 9 over 5. Did you see that?
Yes,
Is it a function or not?
it is not a function.
Very good. Okay, are you seeing a pattern here? Let's analyze.
Yes.
Okay. What you will do, class, if that happens, just look at the exponent of y. Okay? If it's even, it's not a function. And if it's odd, when you isolate the y, like in this case, this is a function, right? Correct? And if the exponent of y here is like 1, it's a function.
Yes.
Okay, so for G, Hassan,
For G,
function, well, we
it's
just discussed it, it's not,
yes,
right?
it's not a function.
For letter I,
For letter I, um, I don't
look
wait.
at the power of y. It's even, right? So
Even.
meaning
Yes.
if you isolate y, you're supposed to get the positive and the negative part, right? Because it's even.
Right.
So this is not a function, correct?
It is not a function.
Okie dokie for letter K.
It is a function.
It is a function because because if you isolate y here, you'll just get whatever it is. You're not getting a positive and a negative part. For letter M,
It is a function.
it is a function because the power of y is 1. Letter O,
It is a function.
it is a function, right? Letter Q.
For this, I had a question.
Okay.
Does the rule for positive and negative only apply to squares or any even
No,
number?
any even power.
Yeah, so this would not be a function.
Very good.
Wait,
Okay.
Professor, I have a
Yes.
wait, so to be able to tell if something's a function, it's as long as it doesn't have the y doesn't have a like exponent. Is that what
An exponent of even power.
so if it has a odd number as an exponent, then that's
Like this one, like letter E.
okay. And
Right,
that's
letter E, as we agreed a while ago, it's a function. Because
okay.
if you isolate y, y will just be the cube root of x, not the positive negative cube root. The
Okay.
positive negative only happens if the exponent is an even number.
And do we just look for that to determine if it's a
Well,
function?
yes. Well, it's like this. For these types of questions, these are just really basic questions.
Okay.
There could be more, what do you call this? More complex equations. Okay, that's possible. But we're just learning and we're just recalling, if something's a function or not. You're just be given these simple functions or equations. Does that make sense, George?
Yeah,
There's
thank you.
infinitely many more complex functions, but I wouldn't be asking you that because we're just starting, right? Does that make sense, George?
Yeah, I see.
Okay,
Thank you.
okay. Yeah. But again, things are not as simple as this in real life or when you get to higher mathematics. Okay? I hope that makes sense. Okay, it's like this, class. This is very important. George, you want to help me?
Yeah, sure.
Okie dokie. Thanks, Azan. You worked hard. Good job. Okay. Now, there's what we call a vertical line test. It's like this, class. Whenever you have equations, whenever you have functions, you can actually graph them. Okay. Now, let's just analyze this, George. Okay. So letter A, we agree that this is a function, right, George?
Yes.
Okie dokie. Now, this is a graph of a line, right?
Yeah.
We all agree that. So line, okay, let's generalize. Let's just visualize it in general, okay? So this is your XY, you have a line. Okay? Now, here, for every value of Y, there's only one X, right?
Yeah.
Or for every value of X, there's only one Y, vice versa, right?
Yeah.
Correct? For any line. Now let's look at the next one, because I just want to generalize this one. Letter C. What is that graph? If you would recall from your algebra or pre-calc.
Is it a parabola?
Yeah, it is a parabola, right? So this one, letter C. So, or in general, for any parabola, right, it would look like that. Correct?
Yeah.
A parabola. Meaning, if I have a value for Y, say this one, how many X's do you have?
2.
2, right? Correct? So this one and that one, which is still okay because it's still a function, right? 2 X's, 1 Y is still fine, correct?
Yes.
That's why we said that that's actually a function. Okay, now let's look at this one, George. Okay, let me give you a simpler equation, George. Do you remember this? For example, you have x squared plus y squared equals 4. What is this graph? The graph of this equation, George?
Is it like a wave?
It's a circle, right?
Oh, circle. Okay.
Circle centered at the origin with radius what? Radius 2, right? This is 2 squared. Correct?
Yeah.
So this is a circle centered at the origin with radius 2. What's the graph of this one? Now, basic question, George. Is this a function or not?
No.
No, right? Why? Because if you isolate y, you would have 4 minus x squared, positive, negative, the square root of that whole thing, correct?
Yeah.
Let me write it down so you will, the class would see it. So that's y equals 4 minus x squared, square root, positive, negative part. Okay, that's why it's not a function. Meaning, for a value of x, 1x, how many y's do you have? 1, 2, right? Correct?
Yes.
For 1y, there's 2 x's. You don't want that. It's not a function. Therefore, what do you notice? We call this a vertical line test, class. And this is one way to check, to see if the graph of a function, given the graph of the function, you would know if the equation would determine if it's a function or not. Because y is a function of x, f of x. Can you read the vertical line test, please, George?
Yeah. A curve in the coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once.
Okie dokie. So it's like this. You have a graph of the function. For this one, what happens here? A vertical line test, meaning anywhere, if you create a vertical line test, a vertical line, if that vertical line that you created only intersects the graph in just one point, that means it's a function. It's not a function if you do the vertical line test. Okay. So if, for example, I do this vertical line here, one vertical line, and it intersects how many times here, George, in this
It
specific
intersects twice.
twice, right? Meaning it's not a function. That's why here, this one, okay, this is the graph, the red thing. I drew a vertical line. It intersected the function in 2 points, or intersected the graph in 2 points. That means it's not a function. Now, for a parabola, for example, does this pass the vertical line test, George?
Yes, it does.
It does, right? Because anywhere I put a vertical line, it only intersects the graph in just 1 point. So that's one way to check if you know the graph of a function to say that if it's a function or not. Okay, so let's do this really fast, George. Can you read 1.14, please?
Yeah, use the vertical line test to determine whether the curve is a graph of a function.
Okay, let's do 1 to 12, George, really fast. The first
Okay.
one.
Yes, it's a function.
Okay, number 2.
Yes, it's a function.
Very good. Number 3.
Yes.
Very good. Number 4.
No.
Yeah, obviously. Number 5.
No.
Number 3. Oh,
Yes.
we have 2 3s here. Number 6. Yeah, it's yes, right? Number
Yeah.
7.
Yes.
It is a function. Number 8.
No.
No. Number 9.
Yes.
Number 10.
Yes.
Number 11.
No.
Number 12.
No.
Okie dokie. Don't overthink, okay? That's your vertical line test. Any questions, class? We're good? Was that easy, George?
Yeah.
Okie dokie. Now, since you're there, let's just, do you have any questions, class, before George helps me with the next definition? We're good? Okie dokie. George, can you read 1.15, please?
Yeah. A linear function is a function of the form f of x equals mx plus b. The graph of a linear function is a line with slope m and y-intercept b.
Okay, we all know this from algebra, way back algebra and then pre-calc, right, George?
Yeah.
That you could write a linear function of the form y equals mx plus b, where m is the slope and b is the y-intercept, meaning the value of y whenever x is 0. Let's have an example. So y equals, say, x plus 3. And let's just graph this line. The way I want to graph lines is by getting the intercepts. Meaning, for example, there's 1, 2, 3, 1, 2, 3. I'll just get any convenient values for x and y. Usually that's 0. Meaning if x is 0, because this is your x, this is your y. If x is 0, what's y, George?
Oh, 3.
Very good. If x is 0, y is 3. So this is the point 0, 3. And if y is 0, what's x, George?
-3.
Very good. So if y is 0, x is -3. So you have that point. You have 2 points now, and from geometry, 2 points will determine a line, because we know that this is a line anyways. So this is my line. Just imagine that it's straight. I don't really know how to draw really well, but you know what I mean. Okay, so that's the graph of the line. So this is the slope, which is, what's the slope here, George?
1.
Very good. It's always, always, always the coefficient of x, okay? That's your slope. This is the slope. And then again, this is the y-intercept. meaning the value of y whenever x is 0. The value of y when x is 0. Okay? Very good. So if you can write an equation in the form y equals mx plus b, then you have a line. Let's do this really fast, George. 1.16. Can you read the question, please?
Determine whether the given function is linear.
Okie dokie. Let's do A up to O this side. Just tell me yes or no. Is it a line or not? Okay? Letter A.
Yes.
Yes, it is, because, okay, it's like this. The thing here is look at the exponents of x and y. If they're both 1, okay, then, or 0 if it's a constant function, or just a vertical line, then it's a line, right? So let's do letter A. Line or not?
Yes.
Very good. Letter C.
No.
No, because the exponent of x is 2, which makes this a parabola, right? Letter E.
Yes.
Very good. Letter G.
Yes.
Letter I.
Yes.
Letter K.
No.
No, because if you spell this out, you would have x squared plus 4x plus 4, right? Which
Yeah.
would make the exponent of one of the x's to be 2, which is not a line. Letter M, please.
Yes.
It is. Very good. Letter O.
No.
Very good, because this would actually be a parabola. Okay? Any questions on that? Don't overthink on this, class, okay? It's that simple. Can you read to me slope and rate of change, George?
Yeah. For a linear function, f of x equals mx plus b, the
Mhm.
slope of the graph of f and the rate of change of f are both equal to m, the coefficient of x.
What this is saying is that remember, if you have a linear function, y equals mx plus b, right? Or y is f at x, which is equal to mx plus b. We know that the coefficient of x is the slope, okay? And do you remember rise over run, George, from...
Yes.
Okay, rise would be the change in y, right? And okay, let me just show that to you. Let's recall for those who might have forgotten it. If you have a line, say this line, okay, and if you have 2 points, this point and that point, the slope of this one will be that one, the change in y, the change, let me write it as delta y, or the change in y. I'm introducing that delta there because later on when we get to calculus itself, that will be very important. And we'll be using it a lot of times, okay? And this is your delta x. Okay, this is the rise, change in y, and the run, change in x. Okay, now the slope is the change in y. This is m. The slope m will just be the change in y, the rise, over run. And until you get to your calculus 3 or 4 or 5 or higher mathematics, this will be very important, okay? So that's the change in y over. What this is saying, the one you just read, George, is saying that the slope is also the rate of change, okay? So if, for example, later on, this is the distance and that's the velocity, for example, the velocity will be the change here over the change there. Well, I'm jumping and I'm doing some mentioning some advanced concepts, but we'll get to that later on. Okay. Now, can you read 1.17, George?
Yes. Graph the given linear function and find the slope rate of change.
Okay, I won't graph this anymore, but just tell me the slope here really fast, George, from A to M, this side, please.
Okay.
Letter A, what's the slope?
1.
Very good. Letter C.
-1.
Very good. Letter E.
-2,
Letter G.
0.5,
Very good. Letter H.
1.5,
Letter K.
2,
Okie dokie. And letter F.
negative.
Letter M. -2, right? Okay. So any questions on that? We'll get to this anyways later on. We'll have a lot of this later on. Okay. Now I will jump here, even add function. We'll touch that as we go along. Okay. I would want to get straight to trig functions. Any questions, class, before I start with trig functions? We'll just recall trigonometry. Very good? Okie dokie. Thanks, George. You worked hard.
Okay,
Who
thank you.
wants to help me read the definition 1.28, please? Anyone?
I'll go for it.
Jawan? Okay, hold on, Jawan. I'll just make sure I write your name for your bonus point. Okay, Jawan, can you read 128, please?
All right, 1 second. It's loading a little bit. My computer's a little bit slower. It is let T be any real numbers and let
Yeah. Continue on,
Oh,
please.
let P, X, and Y be the terminal point on the unit circle determined by T. We define the sine, cosine, tangent, cotangent, tangent, and am I saying that right? The last one?
Cosecant.
Cosecant functions respectively as follows.
Can you read them, please? Letter A to F, please.
Okay. Cos T equals X, tan T equals Y over X. X does not relate to 0. Sec T equals 1 over X. X does not go into 0. Sin T equals Y. Co T equals X over Y. Y does not go to 0. Sec T equals 1 over Y. Y does not go into 0.
Okay, so these are just definitions of these trig functions: sine, cosine, tangent, cotangent, secant, cosecant. Okay, that's like this, if you would recall. With trig, hold on, sorry, I forgot to switch. Okay. With trig, if you would remember, you would start with a unit circle. Okay, so this is X, this is Y, and you have a unit circle. Okay. Unit circle means that it's a circle centered at the origin with radius 1. Okay, and it's the equation x squared plus y squared equals 1. Now, let me remove this for now. Imagine yourselves as a tiny bug, an ant, probably. And you're traveling in this circle. Okay, let's do counterclockwise for now. Meaning, if I'm a small ant, small bug, I would walk here from here, maybe stop there. Okay, so I traveled a certain arc length T. And this is another point here, which will be, let's call it point P, wherein you would have your value X and your value Y. Okay, that is your X, that is your Y. Now we are defining the functions, okay? The trig functions. It's defined as if I want to get the cosine of that arc length T there, it's just saying that, okay, it's just X. Let's define it as X. So from now on, if you see here cosine, think of X. That's what it's saying. And then for sine, the sine of that arc length, just think of it as Y, that value there. Now let's define tangent. Tangent of the arc length T to be y over x. And if you would recall from trig, that's just sine over cosine or tangent, remember? And of course, the assumption here is that x is not equal to 0. Because this is in the denominator. You don't want any zeros in the denominator. Remember if you would recall from your algebra and from what we talked about the other day. And then cotangent of t will just be x over y. Okay, and then of course, assumption here is that y is non-zero. And secant t equals 1 over x. And of course, assumption, again, x is non-zero. And then cosecant of t will just be 1 over y with the same assumption that y is non-zero. Okay, so these are the definitions of the trig function. Now, I posted, for those of you who are late, you may want to open this in the shell, Canva shell. Go to module 1. And I think I put it under lecture notes by Nada. Click this one. There's trig values there. Okay. Click that one and it will take you to this cheat sheet, which will be very useful later on. Okay, this one. This will be the trig values from trigonometry before. Let's just analyze it, okay? So these are, we're going clockwise here, counterclockwise. There's two ways you could, where the definition of the trig functions would have sense. Two ways would be in terms of degrees or in terms of the arc length, which is in terms of pi, remember? So very basic from geometry. This is 0 degrees, this is 90 degrees, right? And 180 will be half. And then the whole thing will be 360 degrees. Okay, so this will be in degrees. And another will be in radians. And usually it's pi, in terms of pi. Let's just recall the technique for the radians. Because in trig, honestly, when I was teaching trig, my students don't need to memorize anything. They just need to analyze what's happening, because this is what I did when I was your age. I didn't memorize anything, but I could start from scratch. It's like this. Let's just recall, okay? Remember, this is a unit circle, meaning it's centered at the origin, radius 1. Okay? Now, remember, you could define the trig functions in terms of the arc length, meaning arc length would be that length. Now, if I'm a bug again, walking from here to there, meaning I'm walking the whole circle, right? Who was helping me? Was that you, Joanne? Was that you helping me?
Yes.
Okay. Do you remember the formula for the circumference of a circle, Joanne?
I don't really remember the,
Does this look familiar to you?
No, not in a while. I seen it, but like not in a while. All I remember is like maybe like the fractions of the unit circle, and that's all.
Oh, very good. Okay, let's just recall it, okay? The circumference, meaning the total distance that I've walked as a bug from here to there will be the circumference of the circle, meaning the distance from there to there, okay? And by the formula from geometry, the circumference is twice of pi times the radius, right? Whatever that radius is. But this is a unit circle, meaning the radius is always 1, right? Joanne?
Yeah, right.
Meaning radius is just 1, correct?
Yes.
So that whole thing is 2 pi, right? This here from there is 2 pi. Therefore, if you walk from here to there, if you're from here, that's 0. And if you walk around, that's twice of pi, right?
Yeah.
Okay, dokie. If this is twice of pi, half of it will be what?
You said what again?
Half of twice of pi would be what? What's half of that? Just here.
Half. Like, oh, right there.
Yeah.
It would be like
Just pi, right?
pi. Yeah.
Because this is 2 pi. So half of it will just be pi, right?
Pi. Yeah,
If
just
this
pi.
is pi, half of it will just be?
Half of it
Over
would just be pi over 2.
Very good, right? And then this is okay. This is 0, pi over 2 pi. So this is 1 and 1/2 pi, right?
Yes. Yeah.
2 pi, right? As you go along. That's how you do that, okay? So if you want to, if you want half of the pi over 2, that's pi over 4, if you would recall, right? And this is 3/4 pi, so on and so forth. And you can also divide this into 3 and this 6. That's why if you would look at the cheat sheet, these are the values. Degrees, radians, okay? Degrees, radians. And if I may ask you, Jawan, what's the cosine of 1?
The cosine of 1, it would just be like.
I'm sorry, cosine of 0. Sorry. Cosine of 0.
Just sorry.
Cosine of 0 is?
0.
1, right? Okay. The way to look at this cheat sheet is that this is x and y, right? Correct? X,
Yeah.
y, x, y.
That's why.
What is x? It's cosine, right?
Oh, and then the other one is tan, I think.
Right? And the other one, the y value is sine. That's how we defined it to start with.
Okay.
Cosine is x, sine is y. That's all.
Okay. I understand. Okay.
No, you're right. Yeah, it's all coming back now, huh, Jawan?
Yeah.
So if I ask you, what's the sine of 120 degrees?
20 degrees sine.
120.
Under 20?
120.
Oh, 120 would be -1 over 2, right?
Did I say sine or cosine? I think I said sine.
Wait, you said sine? Oh, okay. So not power 3.
Cube root of 3 over 2, right?
Yeah, over 2.
Okay. So that's how to use that. Okay, let's have some fun. Okay, hold on. Try doing this class, and Jawan, I'll get back to you, okay?
Okay.
Let's get all the trig functions. Okay. Say what's the cosine of 7 pi over 6? Just do this class, okay? And then I'll get back to you, Jawan. And then sine of, say, 330 degrees, tangent of pi over 3, cotangent of, say, pi over 2, 90 degrees, say 90 degrees, and secant of 5 pi over 3, cosecant of, say, 3 pi over 4. Class, can you do this, please? Really fast, like I give you maybe 2 minutes to do it. And then Jawan, I'll get back to you, okay? That's just
All right.
just use the cheat sheet, okay? I don't want you to really think about this.
Just use the cheat sheet. All right.
Yeah, I just use a cheat sheet. The one I gave you, the unit circle values. Let me get back to that, okay? So again, for those of you still wondering where to find that cheat sheet, go to your modules, okay? And then go to module 1. Go to lecture notes by Nada. And then trig values. Just click that and you can print it out, download it, or whatever you want to do with it, okay? And if you do that, you will see this very useful cheat sheet. And then let's tell me once you're done, Jawan, okay? So we could start.
I think I'm ready.
You're ready, okay. So these are the questions, class. You may want to write it down because I will be toggling back to the cheat sheet. Okay, what's cosine 7 pi over 6?
Negative square 3/2. Is that right?
Right, very good. So 7 pi over 6 is this one. And cosine will be the x value, which is this one. So negative square root of 3 over 2. Very good. Sine 3, 30 degrees, Jawan.
It's going to be -1/2.
Very good. 330 degrees is this one. And sine will be the y value. So that's negative 1/2. Good job. What's tangent pi over 3 then?
Tangent 503. Let me try to find it right quick. I didn't see it. 5 over.
5 over 3, this one, right?
Oh, okay, yeah. So,
and then tangent is sine over cosine, if you would recall from trig, right? Do you
yeah.
remember that? Hold on, let me just toggle again, okay? Tangent is sine over cosine, right? So tangent pi over 3 is sine pi over 3 over cosine pi over 3. Now, in that cheat sheet, what's sine pi over 3? Let's go back. What's sine pi over 3?
Pi over 3 is square 3/2.
And what is cosine pi over 3?
It's going to be 1/2.
So what is tangent then?
Tangent. Let me write it all down.
Square root of 3, right?
Oh, yeah.
Don't overthink, Jawan. Okay? Now let's do cotangent of 90 degrees. Cotangent from trig, as we know, will be cosine over sine, right? So this is cosine 90 over sine 90 degrees. Correct? So Jawan, what's cosine of 90 degrees?
Cosine of 90, my fault. 90 degrees is going to be 0.
Very good. And what's the sine of 90 degrees?
1.
So this is equal to what? Cotangent
0.
should be equal to, very good.
Just 0.
Very good. 0. Now, secant 5 pi over 3. We know that secant is 1 over cosine, right? From trig. So this is 1 over cosine 5 pi over 3. What's cosine 5 pi over 3, Jawan?
5. Okay, 5 pi over 3. Let me see.
Where is that?
Oh, okay, 1/2.
Oh, wait, I'm still looking for it. Okay, this one. So 1 over 2, right? Cosine is the x value, so 1/2. Right? So 1 over 1/2 is?
It's just going to be 2. It's just going.
Very good. Okay, cosecant will be 1 over sine. 3 pi over 4. Therefore, that's 1 over. What's sine 3 pi over 4?
Sine 3 pi. Let me try.
Where
this.
is that? 3 pi over 4.
Okay, it's just square 2/2.
This one, right? Square root. Sine will be the y value. Root 2 over 2 will just be 2 over root 2. And usually you don't want radicals in the denominator. So you just rationalize this one. So this is equal to 2 square root of 2 over 2. So you're just left with square root of 2. Okay? Because this cancels out actually. Any questions, class? We're just recalling what we learned from our trig class before. And any questions before Jawan continues to read fundamental identities? We're good? Okie dokie. Okay, Jawan, can you read to me? Okay, so this is just using the cheat sheet. And this one as well is the same thing. Let's just recall some fundamental identities. Jawan, can you read the reciprocal identities and the Pythagorean identities?
All right, got you. Let me just go down there right quick. So we have sec t equals 1 over sin t.
Okay, cosecant t
Cosecant
equals
t
1 over
equals
sine t. Okay, let's just try to read it that way so it's less confusing, right?
my fault. And then
So
you
that
have
means, okay, class, that means that the cosecant and sine are reciprocals of each other. That's why we call this reciprocal identities, okay? That means that cosecant times sine is nothing but 1, right? Letter B, please.
our letter B is secant t equals 1 over cosine t.
That means that secant and cosine are reciprocals of each other, meaning if you multiply secant and cosine, it will give you 1. Continue on for letter C, please.
Is it cotangent?
Cotangent, okay?
Cotangent t equals 1 over tangent t.
Very good. So cotangent and tangent are reciprocals of each other, meaning cotangent times tangent would equal to 1. Letter D, please.
Tangent t equals
Sine
sine t equals over cosecant t.
cosine t.
You mean cosine t?
Okay, dokie. So, because cosecant class will be CSC. That's how you write it. Okay, let's go back. Let's just recall. Because some of you might have had trig way back, so we might have forgotten how these are read. Again, this is cosine. This is sine. This is tangent. This is cotangent. This is secant. This is cosecant. Okay, so one of the identities that we had from trig will be tangent, which is sine over cosine. And since cotangent and tangent are reciprocals of each other, meaning cotangent will just be the reciprocal of this. It will just be cosine over sine. Okay? Now we also had the Pythagorean identities, which is sine squared plus cosine squared equals 1. Okay, why? Let me recall, okay, how that was established. Jawan, are you still there?
Yes.
Okay, so we have this, right? We have this fact that we're working on a unit circle, correct? So
Yes.
it's x squared plus y squared equals 1. So this is a unit circle, meaning it's centered at the origin, radius 1. Now, how did we define cosine of t, Jawan?
It's an x.
Very good. Meaning this is cosine, right? This is cosine of t squared, correct?
Just quick thing. The board is the camera is a little bit lower than the board. So
Okay, sorry. Ooh.
It's cut.
Thank you, Jawan. Yeah, because sometimes I don't really see what you're seeing. So okay. Now what is x again, Jawan?
Is cosine is cosine t. It's cosine.
Very
t.
good. Cosine t, but you have a square there, right? So this is cosine squared t. But what is y by the definition?
It sin t is
very good. Sine t, right?
Yeah, sine t, my fault. Sine.
And then you square it, so sine squared t equals 1. So this is your first Pythagorean identity, which is actually what's on the notes, right? Let me go back. This one, right? Make sense? Okay, now, where did we get the rest? Remember, we start with this identity. We've established this one. Now, Joanne, I will divide everything by cosine squared. Okay? So I'll divide this by cosine squared t. I'll divide this by cosine squared t. And I'll divide this by cosine squared t. Okay? So I'm dividing both sides by cosine squared t.
Do one of them cancel out?
No. Okay. What's cosine squared t over cosine squared t, Jawan?
It's just one.
Very good. What is sine over cosine?
I'm a little bit lost there.
Okay, sine over cosine. Let's go back. Okay.
Oh, it's just y. It's just y over x, right?
Which is tangent, right?
Tangent, yeah.
Sine over cosine is tangent. Cosine over sine is cotangent. Okay. What's sine over cosine again, Jawan?
Wait, it's tangent.
Very good. But there's a square there, right? So tangent squared t. What's 1 over cosine again?
It's just gonna be x, or like when
Let's go back.
over
Okay.
x.
1 over cosine. What is that? Secant, right?
Secant, yes, secant.
Agree? Okie dokie. So this is secant squared, correct?
Yes.
So this is your next Pythagorean identity. Is that in your notes, Jawan?
Yep.
It is, right? It's actually this one. Tangent squared plus 1 equals secant squared, correct?
Mm-hmm.
That's where we got that. Now let's go back again. Okay, so let's go back. Cosine squared t plus sine squared t equals 1 from that one. Okay, and then we divide everything by, instead of dividing it by cosine squared, let's divide it by sine squared t. Sine squared t, sine squared t. Now, what's cosine over sine, Jawan?
Cosine over sine. Let me look back. Right. It's going to be cosecant.
Cotangent.
Cotangent.
Cosine over sine.
Cotangent.
Okie dokie. So that's cotangent of t, right?
Mm-hmm.
Okie dokie. So cotangent of t. Plus, what's sine squared over sine squared?
Sine over sine is just going to be 1.
Very good. And what's 1 over sine?
Secant.
Let's go back.
Or am I not pronouncing it right? It's basically, I'm trying to say a. I think I'm mispronouncing it.
Sorry, that's cosecant, right?
Yeah.
Cosecant. Okie dokie. But there's a square, right? So this is your last Pythagorean identity. Do you have that in your notes? Yes or no?
Yes.
Okie dokie, which is this one. Okay, so that's where you got those. If you were wondering when you were in trigonometry, that's how you get these identities. Okay, are we good? So I won't touch yet the inverses of trig functions. We'll get back to it as we go along. Okay, I just want us to be reminded of the of right triangle properties. Okay, so Jawan, you've worked hard. Thank you so much. Who wants to help me read definition 1.42 if you don't have questions? Anyone?
I can read it.
Okay. So Jaskaran, hold on. Let me just make sure I write your name. Jaskaran. Okie dokie. So can you read 142, please?
It says, consider a right triangle with
You read it as theta.
Theta. With theta as one of its acute angles.
Okie dokie. So let me just consider this one. Let me remove this so you won't get confused. Okay, So you have a right triangle, meaning this is a right angle. Okay, one of the angles would be a right angle. And this is theta here. Okay, let's just define the sides. This side, which is opposite to the right angle, which is the longest side in this triangle, is what we call the hypotenuse. Okay, hypotenuse. And this side here, opposite theta, if this is defined as your theta, that's the opposite angle. And this one is what we call the adjacent angle, adjacent side, the side adjacent to that angle. And we'll be defining the trig functions in terms of this right triangle. Okay? So the sine theta will just be opposite over hypotenuse. Cosecant will be hypotenuse over opposite. Cosine will be adjacent over hypotenuse. Secant is hypotenuse over adjacent. Tangent will be opposite over adjacent. And cotangent, which is the reciprocal of tangent, will be just be adjacent over hypotenuse. You don't have to remember this because there's a mnemonic that I'm sure your professor has taught you. Who was reciting? Jaskaran, you're the one reciting, right?
Yeah.
Do you remember Sokatoa?
Yeah, Sokoto, yeah.
Okay, let me write it down, okay? Because it's like this will be very useful, especially when you get to your higher mathematics, if you would take higher mathematics, because trig functions, you would study them until you get to your last mathematics, if you would, okay? So just try to digest this one and put this by heart. So ka to wa. That means S is sine. Let me write it down. This is sine. This is cosine. And this is tangent. Okay. Sine is opposite over hypotenuse. Opposite over hypotenuse. Let me change the colors so you will see what I mean. Opposite over hypotenuse. So ka is cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. And tangent will be opposite over adjacent. Tangent is opposite over adjacent. And of course, cosecant, secant, cotangent are reciprocals of this ones. Cosecant is reciprocal of sine, so you just invert it. So instead of opposite over hypotenuse, you have hypotenuse over opposite. For cosine, you have cosine is adjacent hypotenuse. So secant, which is the reciprocal of cosine, will just be hypotenuse over adjacent. And same as with tangent. Tangent and cotangent are reciprocals of each other. So opposite over adjacent will be adjacent over opposite for cotangent. So this is the mnemonic that you may want to remember. Okay. Any questions before we continue? Okay, so let me go back. So these are the trig ratios. Can you read 1.42, Jaskaran?
1.43.
43, sorry.
Okay. Trigonometric ratios.
Mhm.
Find the exact values of the 6 trigonometric ratios of the angle theta in the triangle in figure 2 and figure 3.
Let's do figure 2 first, okay? So let me write it down for a while. Give me time, and you may want to also try that. So here you have theta, and then this is 25 and 24. and you want to get the exact values of the 6 trig functions. And let's do this. Okay, Jessica. So this will be the parts, okay? So this is theta, the angle. So this is your hypotenuse, right?
Mhm.
And this should be your adjacent. And this is the opposite side, right? Do we have the value for the opposite side?
No.
Can I get the value for that, Jessica?
Yeah, using the Pythagorean theorem.
Very good. So, Peter, can you try doing that for me, Jessica? Pythagorean theorem. Were you able to get it?
I was just starting.
Okay, okay. So if you want to get the opposite, so that will be just be the opposite squared equals 25 squared minus 24 squared, right? Is it?
I got 7.
You got 7?
Mhm.
Okay. I trust you. So 7. Let's just see. Hold on. It's not that I don't trust you, but I just want to.
Yeah, it's okay.
I have trust issues, Jaskaran. 625 minus 24 squared, 576. 625 minus 576 is 49. Therefore, opposite is the square root of 49, which is 7. You're getting just the positive part because you're talking of length. So it should always be positive. So very good, that's 7. Now, are we ready to get all the trig values?
Yeah,
Okay, okay. So what is sine?
sine would be 7 over 25.
Very good. So sine is opposite over hypotenuse, right? So 725. Good job. Cosine theta.
Cosine would be 24 over 25.
Very good. So that's adjacent over hypotenuse. 24 over 25. And tangent would be
It would be 7 over 24.
7 over 24. And of course, for the cosecant function, cosecant theta, it will just be the reciprocal of sine, right? Just
Mhm.
invert that. That's 25 over 7. And secant theta would be 25 over 24. And cotangent theta will just be 24 over 7. Okay? So that's, yeah, we're just being reminded of how this works. Any questions? We're good? Okay, the next exercise will just be using a calculator. By now, I know how to use, you know how to use your calculators anyways. If you don't, just, practice back. I'm sure you've done this in your trig class. Now, Jaskaran, can you read definition 1.45? This is really important.
Says the value of the variable that makes the equation true are called the solution or roots of the equation, and the process of finding the solution is called solving the equation.
Okie dokie. So can you read 1.46, please?
It says the root of the equation 2x plus 5 equals 11 is x equals 3 because 2 times 3 plus 5 is equal to 11.
Okie dokie. So the root, you have an equation, okay? So 2x plus 5 equals 11. Now the root of this is 3. Why? Because if you substitute 3 to x, you would have a true statement, okay? So 2 times 3 is 6 plus 5, which is actually 11. Okay, that's actually what you call the solution or the root of an equation. For example, another example. Jaskaran, what is the root of this one? What's the root of that equation?
It would be 2.
Very good. Root or solution are the same, would have the same meaning. That's just the value of x that will satisfy this equation. And usually how we do it was just to isolate x. So I'll just do it this way, minus 7, right? So 5x equals 10. So x will be 10 over 5, which is just equal to 2. So this is a root or a solution to the equation. That's all there is to it. Do not overthink. Now, for this one, Jaskaran, x squared minus 4 equals 0. What's the root of this equation?
Would it be plus or minus the
Very good.
square root of 2? Yeah.
Square root of 4, which is 2, right?
Yeah.
So x is positive, negative 2. There's two solutions because 2 squared is 4, minus 4 is 0. Negative 2 squared, which is 4 as well, minus 4 would equal 0 as well. Now, what's the solution for this, Jaskaran?
Would that be plus or minus 5?
Are you sure?
Or
Okay, if we put 5, Jaskaran, what's 5 squared?
25?
Plus 25, is it 0?
No. Oh, yeah, because when you move it, it'll be negative 25. I see.
So what would you conclude from this one? What will you say?
So would you say it's undefined?
Oh,
Or
you
would
would
you-
say that no real number solution. Because this would have a solution if you are in complex numbers, or you're allowed to use imaginary numbers, right? Because this is x squared equals minus 25. And what is x? This is positive negative square root of negative 25, correct?
Mhm.
And you cannot get the square root of something negative, not unless you allow imaginary numbers. Were you introduced to imaginary numbers before, Jessica? I'm just curious.
A little bit, yeah. I
A
remember
little bit, right?
yeah.
Yeah. Some of you may have been introduced. That means you are introduced to the imaginary number I, which is the square root of negative 1. Because a number does not have any square root if it's negative, meaning this positive, negative. What's the square root of 25, Jessica?
5.
5. Then the square root of negative 1 is just I, right? So the solution to this is positive, negative 5, imaginary number I. But with calculus, we wouldn't be using imaginary numbers. There's another branch of math which we call complex analysis that would actually work on imaginary numbers, but we're not getting there, okay? So at this point, we'll just say that this has no real number solution, okay? Any questions? Or another way to say it is that there's no real number roots, or there's no real roots. Any questions before we get to quadratic function? We're good? Okie dokie. Jessica, can you read to me definition 1.50, please?
It says a quadratic function is a polynomial function of degree 2. So a quadratic function is a function in the form f of x is equal to ax squared plus bx plus c.
Okie dokie. So a quadratic function is a polynomial of degree 2, meaning the highest power that you will see for x will be 2. Okay? Now, it says here, Jessica, that a is non-zero. Why should a be non-zero?
Because
What happens if a is 0? What happens to this part?
you can't
It
it'll
zeroes
just be-
out, right?
Yeah,
It
it'll
zeroes
just be
out.
0.
If a is 0, this zeroes out. And what do you have if that zeroes out?
Then you would just have bx plus c left.
Which is, what is that? That's just a line, right?
Mhm.
That's why it doesn't make sense if you're defining a quadratic function and then you have this as 0. That's why your assumption here is that there should be something here that is non-zero for a quadratic function to exist. Does that make sense?
Yeah.
Okie dokie. Can you read theorem 1.51 and tell me if this is familiar to you?
The root of the quadratic equation ax squared plus bx plus c equal to 0, where a is not equal to 0 are x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a.
Is this familiar? Have you used this before?
Yeah, the quadratic formula, yeah.
Right? Yeah, we've used this a lot before in algebra and pre-calc. Let me just write it down on my board, okay? So if you have ax squared plus bx plus c equals 0, hold on. You may not see, okay? If you have this equation, if you want to get the solution for this equation, x is negative b, so the negative of whatever that is, plus or minus the square root of b squared minus 4a, which is that, times c, which is that, all over twice of whatever that is. Okay? For example, if you have, let's do letter C. X squared, let me see, x squared minus 6x plus 5. Can you do this for me, Jaskaran? In class, can you try this? Get the values of x that will satisfy that equation. Well, there's several ways to do this. You could actually factor it out if you can. But let's just, since we're in the topic of a quadratic equation or solutions of a quadratic equation, let's just use a quadratic formula, okay? This is the quadratic formula. Let's just call it QF. Let's just use that one. Pascal, what is A here in this case?
A is just 1.
Okie dokie. And B?
It is negative 6.
Very good. So let's just write it down. Okay, negative 6. And what is C?
Just 5.
Okie dokie. Okay. Did you get an answer already, Pascal?
I'm plugging it in right now to my calculator.
Okay, let's do it together, okay? Let's see if we have the same answer. And the rest of the class, you can do it as well. So negative B. So that's 6. Negative of negative 6 is 6. There's 2 parts, plus minus. Square root of B squared, which is 36. Minus 4 times 1 times C, which is 5. All over twice of 1. It is 6 plus or minus square root of 16 over 2. 6 plus or minus all over 2. So this is 5, 4, 1. Did you get 5 or 1, Jessica?
Yeah, I got x is equal to 1 and x is equal to 5.
Okay, dokie. Well, that is if you're using quadratic formula, right? But since this is easily factorable anyways, okay, you could do factoring as well. In case you get to this type of problem, what I would always do is factor it out. If I can't, then I get to quadratic formula. So let's just try that.
Problem is that?
Oh, this is, hold on, la 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 la. Letter E.
Okay, thank you.
Mhm. So if we factor it out, this is x and 5 and 1. Since this is a negative, so that's negative, negative. Okay, so this means that x minus 1 is 0, or x equals 1, or x minus 5 is 0, or x equals 5, which is the same solution when you use quadratic formula. Okay. Any questions? Let's do letter D using quadratic formula. Yes, any questions, class? Yeah.
Sorry, just really quick, can you just briefly explain again how you did the factoring from?
Okay, sure, no problem. Yeah, I know factoring. We all hate this actually. Factoring. It's one of the things that you would really need to practice to be able to master. Okay, let's look at this one. Say x squared minus 6x plus 5, right? And you just want to factor it out. So this is equal to 0. Let's factor this out. If the FOIL method, I don't know if you recall that, or that was how it was called by your professor, because during my time we called it the Smiley method. And then I think FOIL method. What else is the term, Nada, that kids are using now for the factoring? Nada?
Yes.
Yeah, what are the other terms? Because during my time, we call it the Smiley method. And I think they call it FOIL.
Oh, yeah, foil. Yes.
What other terms are they using now?
I don't know.
Yeah, okay, yeah. Foil or smiley.
Foil.
Okay, George. Okay, here we don't have a choice, right? But to put x, because it is x squared anyways, correct?
Yes.
Okay, dokie. So now what you will do is you want to find factors of 5. What are the factors of 5? Or think of any two numbers that when you multiply will give you 5.
1 and 5.
Right? 1 and 5. I don't have a choice here because this is a prime number anyways, right? It can only be divisible by itself or 1. Now, since we have a negative 6 here, right?
Yeah.
Correct? And also one way to look at this is that this is positive 5, meaning this should have the same sign, right? Either both positive or either both negative, correct?
Yeah.
Because you want negative 1 times negative 5 is 5 as well.
Yeah.
Positive 1 and positive 5 will be 5 as well. But I have to choose. Is it both negative or both positive? Now, look at this one. This is a negative 6x, right?
Yes.
But had this been positive, this would give you positive 1x and positive 5x, correct? If you do the smiley thing, the FOIL thing.
Yeah.
And this will give you positive 6x, right? Is that what you want? Yes or no, George?
No.
No, right? I want a negative. So this would not work. I change it to negative then. Would this work? Let's see. Smiley, so negative 1x. Another smiley, negative 5x. What's negative 1x plus negative 5x?
Negative 6x.
Is that what you want?
Yeah.
Yes, therefore this works.
Wait, so when we're foiling, we not completely ignore, but we just like kind of ignore initially B, and we just, I mean when we're factoring, and then we do.
Yeah,
Based off of C.
that's correct. You look at this first.
Yeah, okay.
Okay, just ignoring and not really ignoring the negative 6. I get what you mean, George.
Okay.
Yeah,
I
so
understand.
this one first, look for factors, and yeah. Another example, George. Okay, let's do this. I want this to be practiced because I understand the confusion with factoring. Okay, and it's very, very normal that students would have confusion on this one. I'll give you another example.
Okay.
Squared minus x minus 20. Okay, let's factor that out. Okay,
Yeah.
let's do this slowly, George. Do I have a choice for x for here, for the first terms of each of the factors? I don't have, right?
No.
It should just be x and x. Now,
Yeah.
what are the factors of 20, George?
5 and 4.
5 or 4. Let me list it down, okay? 5
okay.
or what else still?
10 to
2 and 10, right?
yeah.
And 20 and 1.
Yeah.
And maybe do you think of, can you think of something else?
Uh,
Maybe,
what?
right? So
I think that's it.
yeah, I think so. Hold on. Let me do 5 times 2 times 2. So 10 and 2, we have this, 4 and 5. 10, yeah, okay, I think that's what we have. We only have that. Now we have different choices here, right? Now, if I do 5 and 4, which seems to be the correct combination, because if I do 2 and 10, let's just, trial and error. If I do 2 and 10, 2 and 10, it would be 20 as well, right? I just need to decide, is it negative here, positive here? Because this is a negative, therefore, they should have opposite signs, correct, George?
Okay. Okay, I see.
Right?
Yeah.
Yeah, but negative 10 times plus 2 would be what? Negative 8, right?
Negative 20. Oh, you meant okay.
Negative 8, right? For
Yeah.
example, this is 2x, negative 10x, and this is negative 8x. And I don't need that. I need negative x. So I don't think this would work. Even if I make this a positive and negative, still it doesn't work. This just
Yeah.
becomes net positive, right? I don't think that works. And you said 4 and 5, right, George?
Yeah.
Which I think makes sense here because I need a negative x here. So
Okay.
4 and 5, right? Which
Yeah.
is 20 negative. That's why they should have opposite signs, correct?
Okay.
So let me do this. Would this work, George? Let's do the smiley thing, the foil. Okay, negative 4x and 5x. What's negative 4x plus 5x, George?
It will be 1.
1x,
It's
right?
1x.
Positive
Yeah,
x.
1x.
But do I need positive x?
No, you need negative x.
Exactly. So I think this should work. Okay? So that's 4x and negative 5x. What's 4x minus 5x, George?
Negative x.
Which is what I need, right?
Yeah.
So I think we're good.
Okay, I understand. Thank you.
Okie dokie. Now, since the original problem is that this is equal to 0, I'll explain to you. This is what's happening here, class, because some of you might still have this confusion. I have 2 factors here. This one times that equals 0. Okay, or let's in general, if I have A times B equals 0, George, are you still there?
Yes.
If A times B equals 0, what can you say about A or B?
One of them is 0.
One of them or both of them is 0, right?
For both of them, yeah.
Yeah, both of them is 0. 0 times 0 is 0. Or one of them is 0. A, whatever that is, 1 million times 0 is also 0. 0 times 3 billion would also be 0, right?
Yeah.
That's why what you're doing, if you're getting solutions, this is a product. Okay? One factor times another factor equals 0. That means there's 2 cases here. That this factor equals 0, or this factor equals 0. Right? George, if x plus 4 is 0, what is x?
Negative 4.
Very good. That's why this is one solution, and this is another solution. If x minus 5 is 0, what's x?
5.
Very good. That's the rationale why you're doing that. Does
I
that
see.
make sense?
Yes, thank you.
You're welcome. Any questions, class? Okay, let's look at another case if you don't have any questions. Let's look at let's do letter D, x squared plus 1 equals 0. Okay, an easy way to do this is to just, isolate x, but I want to do quadratic formula. to do this one. Just to show you what's happening. Okay. Now, George, are you still there?
Yes.
In this case, if I'm using the quadratic formula, what is A?
X squared.
No, A will be the coefficient of x squared, which is
1.
Okie dokie. So what's B then?
0.
0, because it's like this, class. That is 0, if you may. Okay, I'll write it down so you would see. 0x. What was the problem? Plus 1, right?
Yes.
Okay, plus 1 equals 0. I'm changing the colors so you would see. And what is C then?
1.
1. Okay. Now, quadratic formula will give you x equals negative b, which is negative 0, plus or minus the square root of b squared, which is 0 squared, minus 4ac all over twice of a. Therefore, this is equal to square root of negative 4 over 2. George, what's the square root of negative 4? Do you have that in real numbers? Do you have a solution?
No, it would be no real numbers.
Very good. No real number solution. That's what you say.
Oh, that's my final answer.
That's your final answer. No
Okay.
real number solution. Also, one way of looking at this class is if, for example, let me just write it here. I'm really clumsy, sorry. I always do that. Okay, so x squared plus 1 equals 0. Okay. If I isolate x, that is x squared minus 1, right? And x is positive negative square root of negative 1. Again, the same, no real number solution. This would have been an easier way, but we wanted to use quadratic formula. That's why I had to use that. Any questions? We're good? Okay, actually, it's like this. I won't be touching the rest anymore. We'll just touch them as we go along, because I wanted to start with calculus proper by next week. Okay, by Wednesday next week. Again, we don't have class on Monday, Labor Day, and we start on Wednesday with the next section. I'll just show you first, okay? So if you want to read ahead, you can read ahead. So we'll jump. Again, we'll get back to them as we go along, because we may not have enough time. And these are just review of your pre-calc from before anyways. You know them already. Now we'll start with section 2.1, page 27 on Wednesday. So you might want to read in advance, okay? Again, I will send an email by tomorrow regarding your group assignment. It will contain your group mates, and it will contain the questions and all the instructions. Any questions, class, before I let you go? We're good? In case you have any questions, just email me or Nada, okay? Okay, Paulina. We're good? Okie dokie. I'll see you then. Thanks, George. Bye-bye, Nada.